Supplemental math videos from Circle Christian School.
Triangle and circle trig. Okay, trig ratios. Just a little reminder of what they look like. Sine, cosine, tangent, O over H, A over H, O over A, Sa, Ka, Toa. And of course the abbreviations, sin, cos, tan. The reciprocals are just little flippy jobbers here. Obviously, they give you an identity. If you multiply sine by cosecant, it gives you one, which is identity, so that's why they hang around in life. So cosecant is just a flip, secant is a flip, cotangent's a flip. Just remember that somehow, some way, everything goes back to this little right triangle. So to be able to do what you need to do in this next section here, you have to follow the trig hand of life. You have to make a target. You have to identify what's the hypotenuse, what's the opposite side from the target, what's the adjacent side to the target, your HOA. Then you have to figure out what trig you need. Sa, Ka, Toa. In this case, for the first part of the assignment, honestly, all you're going to do is put numbers in for O, numbers in for H, numbers in for A. The fourth finger tells you how to find a side. If the variable or what you're looking for is in the numerator, you have to take that number and multiply it by the trig. If the variable that you're looking for is in the denominator, you have to divide by the trig. The reason why this happens, there's really a reason it happens, I kind of skip a step in doing this, is that there's a cross multiply thing that happens. And number 5, your pinky finger. If you're looking for an angle, sine, cosine, tangent, you're just going to do the -1, second key trig. Theta, the funny little zero with the whoop in it, is the target angle. That's what you make the little circle around. Unit trig just means that a basic side or a radius, whatever, goes back to the basic identity number of 1. So you're starting at 1. There are special right triangles, and that's going to be your 45, 45, 90, and your 30, 60, 90. And I'm just going to work these off the ratio of x square root 2 for a 45, 45, 90. And to be a unit 1, it just means that x is going to end up equaling 1. So if you take a look at the triangles here, let me just see if I can't find a color. I wish I had a highlighter in this. I don't. That the one here, and we have a 1, and I've done the target identified type of thing, helps me build the ratios that they're looking for. A lot of this goes back to that circle that we did, that at 45 degrees there was a radian measure, at 30 and 60 degrees there's a radian measure, and then there's coordinates that go with this at the same time too. And that's where these numbers come from, these ratios. So if we take a look at sine off of 45 degrees here, we see that we have 1 over the square root of 2. Some trig things kind of keep it this way. Others sit there and rationalize the little denominator here. So we would times it by the square root of 2 and the square root of 2, which would give us the square root of 2 over 2. So you have to kind of recognize both of these answers. Obviously, cosine is going to be the same thing. Square root of 2 over 2. And, you know, gee, 1 is just 1. It's nice. Now, the reciprocals, we don't have to do any changing to because we don't have a radical in the denominator. Moving over to the 30, 60, 90, I'm going to make the 30 be the target, but you have to remember that sometimes they may want to make the 60 the target, and if you make the 60 the target, then your O and your A is going to end up changing places. Just redraw the triangle, do it off the 60. So if we do it off the 30 here, we end up with 1 over 2, O over H, square root of 3 over 2, and notice the tan one has a radical down there, so you may see it differently. That would be the square root of 3 over 3. Actually, after you do about 50 of these, you know that the bottom number is going to be what it is, and the top number is like, you know, it being multiplied. And then the reciprocals are just flippies, and note that with secant, oops, that's supposed to be a 3. With secant, we're going to have to do a little bit of that rationalization, love it, rationalizing, would give us a 2 square root 3 over the 3. So again, just recognize it in both ways. Kind of depends on the book, depends on the course, depends on the professor. That's what you kind of get. So they can actually give us words to go, gee, cosine z, which means the z is just, hey, that's my target angle, has a ratio in cosine as 7 over 25. So noting that it's cosine, you know the top number is going to be your adjacent side and the bottom number is going to be your hypotenuse. So you can draw a right triangle, do the labeling, target, label, HOA, and then you know where to appropriately put the numbers. And we can go find the O so that we can have all our little trig ratios by doing the Pythagorean theorem. A squared plus B squared equals to C squared. So that's what I'm going to do. I have an X squared here, or my O, plus the 7 squared equals to 25 squared. And again, all this is doing is practicing a whole bunch of really good basic math, radicals, rationalizing, things like that. It's just kind of in a super ooper duper way. So we're going to minus the 7 squared here. And we get x squared equals 25 squared is 625 minus 49. I don't know. Where's a calculator? You can do it too. 625 minus 49 gives us 576. I'm almost going to bet in a very strange little way that this might be a perfect radical, but let's give it a try. It is. It's 24. Silly me, I should have known it was perfect. And so that's 24. So now we can make all our little trig ratios up in accordance to angle Z. Sine is O over H, so it'd be 24 over 25. Cosine is A over H, so it'd be the 7 over 25. We already have that. Tan is O over A, so 24 over the 7. Cosecant is a reciprocal, so it's 25 over 24. 25 over 7 a reciprocal, and then 7 over 24. Now you go ahead and try number 15 through 19. Hello, let's skip 11.3 because anything in it on an ACT or an SAT, which there may only be one, is just looking to see if you did some pre-cal stuff. No easy way around it. It's just that people with pre-cal would go, whoop, that's what it is. Lucky them. It's not what we need. What we need is to actually spend lots of good time on the ones that we know so that we can think about the ones that take a little bit more time. So, changing measurement, what we're going to do is go from degree. Remember we had that unit circle here. And going out to the outside of the circle, we had unit 1 radiuses. And what we're trying to measure here is a radian. A radian is a measurement of the circumference, a part of the circumference at a certain degree. Some of them are at 30 degrees, some are at 45 degrees, etc., etc. But we can always figure out what the little radian is in accordance to pi, because over here it was 0, and over here on this side was half of a circle, which is pi. And if we go all the way around the circle, it is 2 pi. And you're going, well, gee, why is it pi? Why is it 2 pi? Well, remembering that the radius equals 1, circumference of a circle is 2 pi r. Well, if r equals 1, then basically everything's going to work off of pi. So to change the measurement, we're actually going to do something rather proportional here. So pi over 180 degrees equals our radian measure over degree measure. So if what you want to do is go from degree to a radian, that is, what is, if I have a certain degree, how far is it on the circle? That's radian. So I'm going from degree to actual length measurement. And so I'm just going to set it up as the ratio here. So pi over 180 equals r over the 60 degrees. Fraction equals fraction, so we cross multiply, and that's what I'm going to do. I crossed multiplied, and when I cross multiplied, I got the 180r equals 60 pi. So to get the r by itself, I'm going to divide by 180, lets it say goodbye, and that's going to give us pi over 3. And on your plate, that's exactly what it is at 60 degrees, pi over 3, because it was 2/6 pi, which equals 1/3 pi. Same thing when we're going to change a radian. I want to know how much of the circumference of the circle equals its relevant degree. Again, we're going to do the little cross multiplying. This one's a little bit fancier because we got a fraction up top, but don't sweat it, just break it up. I took the 7 over the 15, I timesed it to the 180 and let it equal the r, and then of course pi times the x. Luckily 15 goes into 180, sometimes it's very nice, 12 times. And so this is what we had as a resultant. And now to get this x by itself, I have to divide everybody by pi, which ends up canceling out, and we find that that radian equals 84 degrees. So at this point in time, just to practice a lot of cross-multiplying type of things and solving for x, we're going to do 1 through 6.